Welcome to The Explainer. So today we are looking at a literally massive shift in how software is built. For the longest time, right, if you wanted to build an automated workflow, you had to manually connect every single thing, node by node by node. But honestly, that era is effectively over. We're officially entering this wild new age of building full-stack, highly deterministic AI applications, and we're doing it using intent-driven systems like the anti-gravity IDE. It's an absolutely fascinating evolution, and today we're going to explore exactly how it all comes together.
Okay, let's dive into this. Just think about it. Literally 6 months ago, workflow builders totally dominated the space. You had to map out every single possible scenario, node by node, and you were almost always bottlenecked by a single AI agent just struggling to execute one task at a time. Well, the new way, these agentic systems completely flips this on its head. Using anti-gravity, you just provide the intent. You literally just say, hey, build this thing for me, and the system spins up parallel agents. You can have 5, 6, or even 7 agents all working autonomously on independent tasks for you, all at the exact same time. It's crazy.
So here is our roadmap for today. We are going to start with the agentic revolution, and then we'll walk through the 5 core steps to actually build these systems: blueprint, links and MCPs, architecture, UI and stylize, and then finally, deploy.
All right, starting with part 1, the agentic revolution. So what exactly is this revolution? It really just comes down to why structured AI development is so rapidly replacing traditional coding. I want you to imagine the smartest AI models out there today. You know, your Claudes or your Geminis. By themselves, they're basically like a 500 IQ intern just sitting in a locked room. I mean, sure, they have massive potential, but if they have absolutely no instructions, no operational playbook, and no laptop to actually connect to the outside world, they're just going to sit there staring at a blank wall. If you give an AI bad instructions, you're going to get bad outputs. It's really that simple.
So, the crucial point is, to unleash that 500 IQ intern, we need a flawless system of instructions. And that's exactly where this proprietary 5-step framework comes in. It's called BLAST. That stands for Blueprint, Links, Architect, Stylize, and Trigger. This framework gives your AI the precise operational structure it needs to flawlessly build literally anything, from a super simple automated script all the way up to a custom $10,000 web app.
Moving on to phase 1, the blueprint. To give the AI that flawless structure, we always have to start here. This is where we establish pure logic before writing a single line of code.
Okay, so in planning mode, we have to force the AI to thoroughly understand the complete vision, and we do this by answering 5 critical discovery questions. Number 1, what is the North Star? Like, what's the ultimate desired outcome here? Second, what integrations are we connecting to? Third, where is the source of truth? Meaning, where does the primary data actually live? Then fourth, what's the delivery payload, or final destination? And finally, what are the strict behavioral rules the system absolutely must follow? Nailing this down right off the bat prevents incredibly costly mistakes later on. Most importantly, it stops context rot. If you've built with AI, you know this. It's that absolute nightmare scenario where the AI just randomly forgets its original purpose halfway through a complex build.
Once that blueprint is locked in, we move right into phase 2, links and MCPs. This is the magical moment where we finally hand that brilliant AI intern its laptop.
To actually give the AI access to the internet and to your business, we use what's called an MCP, or Model Context Protocol. Think of an MCP as a universal remote control. It literally breaks the AI out of its isolated little chat window and lets it reach out, touch, feel, and autonomously interact directly with your external software. It's a total game changer.
Let's put that into perspective. Say we're building an automated meeting management app, a system that agencies routinely sell for upwards of $10,000, by the way. We need to link some very specific tools. So we connect an MCP for Fireflies to pull in the audio transcripts and meeting notes. Then we connect an MCP for Superbase to act as our core database, kind of like Excel on steroids. And finally, we connect an MCP for Notion to serve as our UI dashboard and action tracker. Through these specific links, the AI can seamlessly pass data back and forth between these entirely different platforms.
All right, so with the AI fully connected to the outside world, we need to shift our focus to architecture. This is the technical plumbing required to make the whole system highly reliable for agency clients. Now you might be wondering, here is the massive challenge when building AI systems. Large language models are inherently probabilistic, right? If you ask them the exact same question 100 times, you might get 100 slightly different answers. But a business, A business needs 100% predictable outcomes. If you're building this for a paying client, the workflow absolutely must be fully deterministic. So, how on earth do we bridge that gap?
Wow, we solve it by completely separating decision-making from execution. We use a 3-layer architecture. Layer 1 is the architecture itself. These are strict, technical, standard operating procedures, or SOPs, written out in simple markdown. Layer 2 is navigation. This physically routes the data specifically to prevent the AI from quote-unquote thinking too much, or going rogue off script. And then Layer 3 consists of the tools. These are deterministic, testable Python scripts that just do exactly what they're told, every single time, without fail.
And that brings us to the absolute golden rule of the architecture phase. If the logic of your app changes, you must update the written SOP before you ever touch or update the code. The written standard operating procedure has to act as the ultimate, unchangeable source of truth. That is what keeps your AI aligned and keeps your app from breaking.
Okay, so functionality is great and all, but let's be real. A confused buyer never buys. And that brings us to phase 4, UI and stylize.
This is really where the anti-gravity IDE shines. We take our highly functional raw localhost backend and we seamlessly shift gears right into design mode. We can use a model like Gemini or Claude to style the entire application. We literally just feed it our strict brand guidelines, our color palettes, our fonts, and we have it instantly vibe code this beautiful front end. Guys, no more spending 3 hours pulling your hair out trying to center a div in CSS.
Now, what's really interesting about this whole concept is UI sniping. Look, most of the internet isn't reinventing the wheel with design anymore. Instead of manually writing custom CSS, you can just go to open source libraries, find an absolutely gorgeous chat window, a stunning border, or the perfect animated button, and simply extract that component's code. You feed that specific code to your AI, and it rapidly injects that premium 5-figure agency styling directly into your app, instantly. So, the styling is perfect, the back end is totally robust, which means it is finally time for phase 5, trigger and deploy. Let's take this masterpiece off our local computer and launch it into the real world.
And this brilliantly illustrates the 2 main deployment paths you have, depending on what you've actually built. If it's a completely autonomous system, say something that needs to scrape a website every 3 hours without your laptop even being open, you'll deploy to a platform like Modal. It runs all those back-end triggers reliably while you are fast asleep or hitting the gym. On the flip side, if you've built a public-facing dashboard or a live website for a client, you deploy that to Versal, which beautifully hosts your front end for the entire world to see. By combining the anti-gravity IDE with a highly structured Blast framework, you completely eliminate that old single-agent bottleneck. You're moving from clunky manual workflows straight into intent-driven software creation. So, I'm going to leave you with this final thought. If you had a 500 IQ intern armed with the exact blueprints, fully integrated tools, and a reliable parallel agent system that ran completely autonomously while you slept, what would you build first? Thanks so much for joining us for this explainer, and we'll catch you in the next one.